Hello everyone, and welcome to our webinar on JavaScript Secure Code Analysis 101. I'm Nandini Bharadwaj, the Operating Officer at CyberWarFare Labs, and I'm excited to have you all here with us today. So, let's get started. Before we start, let me tell you a bit about us. CWL is a leading cybersecurity infosec company offering comprehensive solution to help individuals and organizations to develop essential cybersecurity skills. Our offering includes the Learning Management System, that is LMS platform. Here we provide the enrolled users with course study materials including the HD videos and PDF for a wide range of cybersecurity course. The second one is Cybersecurity Playground, that is CCSP portal, where we offer a theme-based lab designed to simulate real-world scenarios. Users can start the labs at their own convenience, provide flexible hands-on practice. And number third is Infinity Learning Platform. So it's a plug and play platform offering immersive learning experience with challenges across red, blue, and cloud security domain. CWL also support customized on-site training requests and accept bulk order for corporate training needs. For more information or to place an inquiry, you can contact us at support@cyberwarfare.live. This is all about the company. And moving further, as promised, we are excited to share that you will receive your attendance certificate and video recording with the PDF material of the webinar. Also, we are giving away our most popular and latest launch, that is Certified Cybersecurity Engineer course, to anyone lucky winner. So if you want to participate, I'll just drop a link in the chat and you just have to comment why you deserve to win that course. Along with that, all the participants who are attending the webinar will get guaranteed access of Infinity Learning platform just after the webinar. So thank you for being part of this engaging session and we look forward for your continuous participation. And here, without further ado, I would like Enoch, the speaker of today's webinar, to take over.
So, hi everybody. I hope you guys are doing well, and I'll be presenting a webinar on JavaScript Secure Code Analysis, and a bit about myself. Um, I'm Enoch. I am a security intern at CyberWarFare Labs, and I'm a curious learner, and I like to work with code. I also like memes, so you will be seeing quite a bit memes in the slides. And also, this is my first webinar, so please bear with me. Okay, and we will be covering a few things in today's webinar. So first, we would be having a small intro to secure code, and we'll discuss why secure code is important and what is secure coding. And second, we'll move on to software development lifecycle and also software testing lifecycle. So both are important things to understand before moving into secure coding. We'll discuss the stages of the development cycle and the testing lifecycle. And third, we will discuss the fundamental secure coding practices, how a developer would take steps to secure the code, and then a few techniques which we can implement when practicing secure code. And fourth, we'll discuss how to approach a code snippet. If we have access to a code base, we'll discuss how we can approach the code snippet. We can find flaws and issues, security issues, and we'll see how we can try to exploit it and how to fix it. And fifth, we'll have code review. So I'll be having a few code snippets with me, and I'll be sharing that. The code will have flaws, will have security flaws. We'll discuss the flaws and then how we can fix that. And we will end with a conclusion and a small Q&A if you have any doubts. So let's get right into the slide. Introduction to secure coding. So what is secure coding? So secure coding focuses on preventing security risk throughout the entire software development lifecycle. So even before writing code, secure coding is present. So in the planning stages or in the in initial stages, we will implement secure coding practices. Um, we will have we can have the frameworks. We can have secure methodologies which we can follow while even before um, writing code. So the basic fundamental concept is that security is from the start, rather than creating applications and then deploying it and later testing for security issues. We try to integrate security from from the beginning itself. And it is the foundational element because security is so critical. We cannot neglect that. So um, we implement security measures right from the beginning, and this is helpful when this helps us when we do not want we do not want to have load on security testing later. After the application is deployed, we can identify the risk in the code and then secure it from the start, and later we would not be facing much security issues later. Although security issues will be present, although we cannot prevent security flaws, but we can try to kind of reduce the attack surface, and also it reduces the need for security patches later on. Although we will have to patch it, it is a continuous process. We cannot completely avoid it, but the attack surface, the workload later will be reduced greatly. So if we implement secure coding practices from the starting. And now we'll talk about software development and software testing lifecycle. So those are from the computer science background, and they will have an idea what I'm talking about. So software development lifecycle is kind of life cycle where we have a few stages, we have a few phases where which is required before while developing an application. So as you can see here, we have quite a few stages, and the main fundamental concept is that we use this framework or this life cycle to plan, create, test, and maintain software. And this is to ensure that the software is developed efficiently, and that it meets the user needs, and it works properly. So we will not be focusing too much on software development lifecycle, but I will be explaining the each stages. So always software development lifecycle starts with requirement analysis. So in this stage, the developers, they communicate with the stakeholders, they communicate with the clients, and they discuss what the software is actually needed for, the requirements for the software, what the software needs to do, and what are the problems the software is solving. So we try to analyze and gather the requirements that are needed to develop the software. And the second stage, as you can see, is planning. So planning, in this phase, they plan how they can develop the software. They create teams. They also organize the task. They create strategies. They create plans. They create blueprints for the development process. And third, we have architectural design. This is where we create the environment for the development. We use tools. We uh, we basically try to create a safe environment for the software building process, and uh, and after that we will have software development. So this is where actually the software is actually being developed by developers. So the developers form a team, and then they actually start implementing the practices which they have gathered in the previous stages, and they actually start developing the software. So after that, they have testing. So this is a continuous process. So the software that has been developed has to be tested. We cannot directly publish it to the internet or give it to the stakeholders. It has to be tested for quality and security. So the testing process here deals with the testing, either the quality testing or the security testing. So we will be focusing more on the testing part of the life cycle. So this testing itself it's a cycle, is a life cycle of its own. So as you will see in the next slides, so in testing they test for security issues, they test for quality issues also, and at the end deployment. So if the software meets the requirements, if all the test cases are passed, or if the testing is satisfactory and the results are satisfactory, they will deploy the software, they will be presenting it to the clients, or they will be publishing it to the internet. So this is all about software development lifecycle. So focusing on this testing stage, we have something called software testing lifecycle. This, as I mentioned, the testing part, it's itself another cycle. So we'll be paying close attention to this cycle here. So it's the same thing, almost the same thing. And first, as usual, we have requirement analysis. We will need to define the outcomes for the software testing life cycle. What do we want to accomplish, and what are the results that we're expecting. So first requirement analysis, they will talk with the developers, they will try to understand what things to be tested and all those things. And next is test planning. Here they will plan out what to test, what features to test, or what are the methods that they should be testing, what are the tools that they should be using for the test. So the test planning phase includes that. Then we have test case development. So this is where actually the testers actually write test cases for the software, or they have some kind of margin or some kind of bar for the software test results. So this is where they develop the testing strategies, and then they move forward with that. Now they have environment set up in the next phase, where they create an environment for testing. They have to fulfill the hardware and the software requirements. So they have to use tools. So they'll be defining which tools to use, what platforms to use, and what environment to use for the testing setup. Then we have test execution. This is where actually the test happens. So the testers actually perform the tests in this stage. So they will be testing for either security, quality also. That is also included in the test execution phase. And at the end, we have test cycle closure. So in this phase, the testing results, the results of the test case are being presented to the developers, to the shareholders, or to the clients, and we basically document an entire process, and then we have the outcome of the test. We see if the test passed the bar, or if it meets the requirements. So we'll have test closure, and if the test results are not satisfactory, they will be going back to the development cycle, and then they would redevelop or make the changes which are necessary, and then test again. So this is a recurring process. So until the software meets the minimum requirement, it is tested, and it is redeveloped, and changes are made. Um, okay, now let's move on to the as you discussed, we have the phases here. So it's mentioned in the slide. So requirement analysis, we understand what are the risks to consider. We plan the test, we develop the test cases, as I mentioned, and the environment setup. So all those hardware, software, and tools for testing are actually defined in this stage. And then we have test execution and test cycle closure. So in test execution, we run the test, we see how the software behaves, and we see if we have any flaws or issues, and we document this process. So documentation, it plays a crucial role. We have to document everything when we are testing for flaws, so that we can use that later as a reference, and fix those issues. And we have test cycle closure, where we finalize the testing process, we present the documentation, and we suggest for future improvements or future testing needs. So that is all about software testing lifecycle. Now we'll discuss about fundamental secure coding practices and techniques. So why does secure code matter? Why should we even consider secure coding? So secure coding practices, they protect sensitive data, and they prevent security flaws and vulnerabilities. Although security flaws cannot be completely avoided, we can minimize the attack surface, as I mentioned before. And they ensure that the application are resilient against attacks. They have some kind of defensive mechanisms. The applications are not completely insecure. They have some kind of defense against attacks. So that is one of the reasons why secure coding matters. We can also minimize the breaches, risk of breaches, and safeguard user trust. So if there are a lot of users using our application or software, once once the software or application gets breached and the user's credentials or sensitive data are being exposed, the trust in the software tends to decline. People do not generally have the same kind of trust they had in the beginning, so they doubt the security posture of this software. So to prevent against that, even though the application or the software gets breached or gets exploited, users data must be kept safe. Even though there's an attack or there's a breach, the impact should not be extreme. We have to have mechanisms to kind of reduce the attack surface and impact. And also secure coding practices, they are not specific to one programming language or one technology. The concepts are same. They can be applied to various other technologies, various other programming languages. So knowing about secure coding is actually helpful, and we can implement in other ways or to other softwares and technologies as well. So now we'll move on to fundamental secure coding practices, and these are some of the things that we consider as fundamental concepts for security. Security by design. So as you can see in the slide, we try to integrate security from the starting itself. As I mentioned before, we try to implement security even before coding, even before writing the application or writing the software, writing the code. Even before that, even during the planning, they try to integrate secure practices within the software development cycle. And we have password management. So this is one of the most basic and things, basic standards that we have. So the we have to make sense to use a weak algorithm. We have to always use industry standard hashing algorithms to secure the credentials safely. Even if the application gets breached or user credentials are leaked or breached somehow, the attacker will not be able to have much impact because of the strong cryptographic algorithms used. So this is one of the most basic standards that we have to follow. And we also have access control. So basically, we have to be sure that we only give what's necessary to the user. So we should not give anything more than what they require. So permissions are always critical, and we have to carefully think and plan before giving permissions to user. Every user must be treated as an attacker, as a potential threat. So we have to give them the bare minimum which they require. We should not give anything more than that. Then we have error handling and logging. So sometimes when we see when an application breaks or when a software runs, or you must have seen when you enter something to a website, it suddenly causes an error, it crashes, or it causes an error. So in that, we might be able to see the file paths or the system configurations or some piece of code. So that should be completely avoided, because that would give attackers something to work with, and they can potentially leverage that into other attacks. So most common is that file paths are exposed, or some parts of the code are exposed. So we have to be sure that we send proper error messages instead of just throwing out the error to the user. So that is also one important thing. And next is input validation. We must never trust inputs from any user. So as I mentioned, we must treat every user as a potential threat. We cannot trust any user. So whatever the input we receive from them, we have to always verify and validate it. We have to sanitize the input so that it does not break any of the program flows. So, and then next we have system configuration. We have to always be sure to configure things properly. Most of the attacks happen because something is misconfigured. So we should always try to configure things. We should always have proper configurations um, for the if for the software. And next we have threat modeling. We can basically basically plan in before what are the threats that can that are potentially possible, what types of attacks that that can happen. So we try to create and think about situations where attacks really happen, even though it is not. We can try to simulate attacks, and then we can be prepared to have defense mechanisms against it. So that is also one important practice of threat modeling. So as I was mentioning, as I was mentioning, yeah, threat modeling. So we can simulate attacks. We can have kind of an idea how the attacks would happen, and we can try to create defense mechanisms against it. And as I mentioned, cryptographic practices, we must always follow the industry standard cryptographic encryption algorithms. We should not be using any uh, weak cryptographic algorithms to encrypt the user credentials. So this is also one of the most important topics of secure coding. And we should always regularly conduct code reviews. Um, so that's what we're going to be learning in this session, and the importance of code review we have seen before. And it's always important to review the code once you wrote it, and even before publishing the code or before pushing into production, we must always review the code and then see if anything is flawed in the code, in the logic uh, of the code. And then we can use automated security scanning tools. We can use tools like Sync and SonarQube to automatically detect if security flaws and vulnerabilities in the code. So those tools actually help us find flaws in some way, not at least if it cannot completely mitigate the security flaws. We have some kind of mechanisms to find these common security flaws. And also dependency management, which we can always use tools like Sync and OWASP dependency checker to monitor for any flaws or existing flaws in the open source libraries. So when you're using libraries that are open source, there are chances that there might be flaws, there might be actively exploited issues in the libraries. So we can use these tools, Sync tools and OWASP dependency check to scan for those. And then we can use those same tools for CI/CD integration, since a lot of code is being pushed. We can automatically keep a track of the security issues. We can automatically set mechanisms to that will autonomously scan for any non issues or security flaws. So that is also possible. Now let's look how we can approach a code snippet. Now um, so approaching a code snippet is we have to follow certain standards. We have to follow certain kind of certain kind of consistency, or we need to have consistency when we are approaching a code snippet, and that would really help us catch security flaws. We need to move in a structured way when we are approaching a code snippet. Now, the first point and the most obvious is understand the context. Without understanding the context, we will not be able to review the code. We need to know how the code flow works, uh, how data is being passed, and how data is being um, is being sent over to the program and to the lines of code that you've written. So we have to understand the context, and we have to always understand how the application is working to have a better understanding. And we can also read the code and see how the code works. So that is kind of important when we are approaching a code snippet. And we can always look for the common exploited issues, security flaws. We can look for excesses in SSRF, and we can also test for path reversal. So those code. So whenever we have an input parameter, whenever we are taking an input from the user, we can always scan those. We can always look in those pieces of code and see if we are properly sanitizing the input, if we have good sanitization methods and validation set up in place. And as I mentioned, analyze data flows. We need to always verify how data is being flown. How data is being passed on to other variables and arguments. We have to understand the structure. So, and also we have to verify input validation. Treat every input as malicious, and then we have to uh, set up mechanisms. We have to validate. We have to use um, uh, proper functions to restrict the user input, or to kind of verify and validate the user input. And we need to also make sure that we sanitize the user input. And next we have review access control. We have to always review the access that we have given. As I mentioned, giving wrong access will turn disastrous. We should not give um, more access than that's required to a user. So we have to set up things like intrusion prevention system and intrusion detection systems all over the place. So that will help us kind of alert us when there's kind of a security issue or security breach, or when someone is trying to access things that they're not supposed to do. So these things help us, and we have to always check for hard-coded credentials. So it's obvious not to put in any hard-coded credentials in the code. We must also never pass in API keys and tokens and all those things in the code. We must also always use proper industry standards when we have to do that. So even using credentials or even passing credentials in the code, it's a very bad idea. So we must always look for any of those. If they're present, then we must try to avoid it at all cost. And we can always review error handling. So as I mentioned, giving out too many information when an application breaks or application crashes, it often displays the error message, and it might have pieces of code, or it might have the file system path and all those things. So we must always make sure that we do not send out any information regarding the system or the code. We must also always create a proper error response mechanisms. We must always try to prevent the code output from being generated to the to the user interface. And we can also use tools and techniques to perform static analysis. And in JavaScript especially, we can use linters to reduce this kind of issues. We can use many static analysis tools, and we can identify security flaws, or potential security issues early on. So now we have code review. We're going to review a few pieces of code. We will be touching on um, three of the security issues, and we will be looking at the code of those flawed applications, and then we will walk through how the code is being misused, or um, how the code is being exploited. So first, we'll focus on very basic common issues, as this is aimed at beginners. So we will be having kind of well-known issues. We'll be looking at well-known issues of the code. So first we have path reversal. So we all know what path reversal is. So even if you are not familiar with that, I have written some of the details here. So path reversal happens when we when we take in basically most of the time when we take user input, and those inputs contain some illegal characters or something, and then they are able to read files of the system. They are able to traverse and move to different directories and different paths to view the contents of the file system. So in JavaScript mainly, as we're focusing on JavaScript, but the concept applies to all the programming languages and technologies. So in JavaScript, we have something called file system read file functionality. So when using this, we have to be extremely sure, extremely careful to sanitize the user input, and then to not let um, to not let any illegal characters pass into the to this functionality. And we have to be very careful when using it. So what a read file will do is it will read the contents of a file that's present, and then it will display out the output of or the content inside the file. So we have to be careful with that. So most of the attacks happen when we do not verify the user input, or we do not sanitize or clean the user input, and then we just um, let the user access the files that they request. So we need to have proper mechanisms. If we do not have proper validations, or if we have very basic validations, the attacker can bypass that. So they can use methods like URL encoding, or double the payload, or double characters, and they can bypass the security measures. So now let's look at the code. Now we have an application which is written in JavaScript. We have used Node and Express. Now we have a route called file. So the file route, what it does is it takes in the user input. So the user can input a file name, and that the file names, the contents of the file would be displayed. So we have a route for that. And now so our structure, our directory structure is like this. We have a folder called files, and inside that we have a file called hello.txt. So that contains some messages inside that. So what we're doing is we have a, a directory called file, and then we are giving the user the kind of um, user the option to request any file name, and it would display the contents of the file name. So here we are constructing the path. We're using the current directory, and then we're appending it the files string. So that will basically help the program access the files directory, and then we're passing in the file name. So whatever if the user requests a valid file name, and if we have that, we will send them the contents of the file. In case if we do not have the particular file that they're requesting for, we're going to send them a 404 error saying the file is not found. And so that is what it's doing. And here we just have its port running, and then we just console logging the server has started message here. So the idea is that we are allowing the users to type in a file name. Now we're constructing the URL, and then we are sending out the contents of the file name. And if the particular file does not exist, we're going to send them an error. So now let's what could go wrong in this code? Everything seems fine. We're allowing the user to enter in a file name, and then if we have the file, we're displaying the output to the user. And if the file does not exist, we're going to send them we're going to be sending a 404 error saying file is not found. So what could go wrong? Now let's try to exploit it. Now, if you normally go to the since I've started in my local host, and it's in port 4002, and see, as we can see, we have a file. The we can request a file parameter, and if and then we can give in the file name. So we have something called hello.txt here. Now when when we input the hello.txt, the file has actually exists in the file directory. So the contents of the file is going to be displayed here in the browser. So now in case if the file does not exist, it's going to be giving an error saying 404, the file is not found. And since we have the hello.txt in our file system, in our files directory, is going to be showing the hello output here. And what could go wrong? And if we can give in inputs. So since in this code we're not actually verifying anything, we're not actually verifying if the user input um, is accessing some other directories which they're not supposed to. We're not verifying. We're not having any mechanisms set up here. So the attacker can actually traverse the directory. So in Linux, if we use two dots and a slash, it goes back to one directory. So in my system, the etc password is kind of in behind six directories. So I've used six path traversals here, and then I've tried to display the etc password file. And if you can see here, when we um, when we traverse and given the file name, it actually displays our files, the contents of the password file here. So that is quite dangerous. This is happening because we do not have any mechanisms that restricts or that checks if the user is trying to access something which they're not supposed to. We have given them the complete power to access any files that they want, and this is actually very disastrous. Now imagine if the process is running as root. They can actually see the contents of etc shadow. They can view the ssh keys, and that would be a complete compromise of the system. Now what we have done is, now I've added one more line, and it has some kind of security mechanisms where we have written regex inside, and we have also used the file name dot replace functionality. So what this basically does that is that if we have any characters that that has two dots and a slash, we're replacing it with an empty string here. Now in this case, in the previous case, we have um, dot slashes here all over here. Now we're checking if the user input has any of those characters. We're going to be replacing it with an empty string here, so that attacker won't be able to access or input the dot slash string in the input. If they do so, they would not be able to view the contents. So we have some kind of restrictions in place, and the rest of the code remains the same. If the file does not exist, we're going to be sending a file, a 404 error. And if it exists, we're going to be sending the contents of the file. So we have added one code, and we might think we're pretty secure. Um, we have kind of we kind of have a mechanism to replace this particular path traversal string into an empty string, and let's see if it works. Now we have passed in the same payload here. We have used dot slash here 6 times, and we are trying to access the etc password. This time we get an error saying file not found. What is actually happening? So we have actually consoled out the input. So whatever the user is inputting, uh, or giving as a parameter, or giving as a value in the file name parameter, that will be displayed to my logs here. So as you can see, even though we have used dot slash 6 times, the out the output, I mean the input the server is receiving is just etc slash password. Why? Because we have actually written the regex to replace this dot slash with an empty string here. So that is why we have etc password, and etc password is not does not exist in the in the files directory. So that is why the file not found error is being given to the user. And we think that this is pretty much it. We have kind of eliminated the possibility of path traversal, but that's wrong. And now if I go to other slide, we can actually pass in a payload. There are multiple payloads for path traversal. So we can have now what we've used is that we have doubled the payload. So instead of two dots, we have placed in four dots, and instead of a single slash, we have passed in double slashes here. So the regex that we have implemented here, the mechanism that we've implemented, it only replaces this dot slash string. It does not account for four dots and two slashes. So if we do not consider regex carefully, we will have this kind of bypasses, and these bypasses will actually work. Now if you notice, we have given we have double the payloads basically, and see, we can access the password file. So this actually bypasses the restriction that we have kept. Now if you look at the logs, the first request, it was actually defended from the path reversal attack. We could, and etc password is pre-implemented, and since etc password does not exist in the files directory, so we are sending them an error, 404 error, saying file does not found. The file is not present. And now we have passed in that we have doubled the payload, and we have passed in as a user input. Now if you see the logs, it literally translates to double dots and a slash, double dot and a slash. So basically, the server, it replaced the first occurrence of dot dot slash, and it has left out the other things. So because we have doubled the payload, only the first occurrence of the payload has been caught and has been replaced. So when we use this, when we double the payloads, it actually translates to dot dot slash 6 times, and we can read the contents um, of the etc password. So this basically completely bypasses the mechanism that we have created. And this is also a common mistake that developers make. They do not actually verify or try in multiple payloads uh, for the mechanisms, for the security mechanisms that they have set. So this is why testing is quite important here. We have to try to create bypasses, and we have to try different, quite different ways to kind of bypass the restriction. So here testing is important here, and I've mentioned it in detail why this is happening. So I'll explain it once again. The regex here means, just simply means that if dot dot slash is okay, is present in the user input, replace it with an empty string here. And since we're not accounting for the double payloads, we're not accounting for multiple payloads here. It only detects the first occurrence of the string and then replaces it. So regex is quite confusing, but we have to be careful when we kind of implement regex mechanisms. So it's recommended to use regex for input sanitization or input validation. There are far better ways where we can, through which we can implement, and we can implement security measures against path reversal. So actually, regex is not actually recommended, but because the chances of missing out things are very common in regex, so um, we have better mechanisms. So we'll go through those better things that we can implement to avoid path reversal. Now, to fix this, we have to never use the user input directly. As you saw in the previous code, in the first code snippet, we are completely passing the user input to the server, and there is no restriction, and there's no mechanism to protect against that. In the second code snippet, we had some security measures in place, but um, it could be bypassed. It was able, I mean, we were able to bypass it because the restrictions were not proper, and they have not tested it properly. So those we could bypass it easily. And we have to always reject inputs like dots having dots, slashes, and backslashes, and all those things. We should never pass in such inputs to our program. We should always have some kind of verification and some kind of validation and sanitization to actually reject this kind of inputs here. So we should never allow special characters when seeking user input. And we have to always decode input. I mean, whatever we're getting, we have to decode them. So common ways, when we have to decode the base 64, I'm sorry, URL encoding. So if the input is being passed through a URL encoding, we have to always decode it, and then we have to verify if the input actually contains anything malicious. So we can also use techniques like path normalization, and we can also restrict what the user can access or which files the user can access. We can have a whitelist of we can have a whitelist that contains the folders and files that are actually accessible by users. So we can remove all these special characters. We should never accept those things here when we are passing in the input to the program, and we should um, always make sure that the user is not allowed to visit other directories than they supposed than other directories which they're not supposed to do that. So we must always restrict the user access to a single or a particular directory. And also we we cannot we can we should not depend too much on kind of removing all these characters and restricting them. We must always use techniques like input sanitization. We must always try to reject certain inputs, certain characters, and there is no point in restricting, or there's no point in trying to um, create mechanisms to defend. We must always define a particular set of whitelist folders or files that the user can access. So yeah, as I mentioned, allow listing. So we should only let the users would visit a particular file or directory, and we should not let them access the system files. And there are functions. We can use some functions that safely combine file paths. Since we have seen in the previous code snippet that we're using um, the file name. We're using the file. Sorry, yeah, the file name, and we can see we're using a particular function. So we can there are better mechanisms and there but better functionalities that handle user input safely. So we can use that, and it depends on the various programming languages that we're using. So we can use it. And also, if the available functions are kind of flawed or kind of risky, we can rewrite the functions actually and make it safer. So that is also one remedial practice that we can take. And also, we should never assume that our mechanism is foolproof. So because no code is completely secure, there's always ways to bypass it. There's always ways to, when technology improves and when technology get developed, and when new kind of frameworks and softwares come and even hackers get smarter day by day. So we have to always consider that our, our our system is not foolproof. There is always a chance for attack. There's always a chance for exploitation. So we have to continuously monitor and continuously kind of keep track, keep monitor, keep logs, and then try to use better functionalities and try to improve the code on an everyday basis. So and also, as I mentioned, we have to, writing uh, creating a mechanism is not enough. We have to test with multiple bypasses, multiple payloads. We have to keep testing that. So it's a continuous process. When we have to keep doing it um, when new kind of payloads arrive, we have to try each of these payloads and see if such attacks actually disrupts our mechanism, um, and if our mechanisms are flawed. So we have to keep continuously testing that. And also automated tools. So we can write scripts, or we can use automated tools to do this process. Instead of doing this manually, we can have tools that does this job for us automatically. So we can use such tools also. And now we're going to be looking at cross-site scripting. So this is also one of the most popular attack framework. I mean, attack strategies. And XSS, what it basically does is we can inject malicious code, in this case JavaScript code, and then it exploits the trust of the user, and and the browser trusts the payload and then functions accordingly. So this also happens mostly because of improper input verification, or input sanitization. If our input validations mechanisms are flawed, then we can have attacks like excesses on our system. And also, the impact is disastrous. We can Attackers can basically leverage this kind of XSS flaws, and then they can compromise the entire system here. So we have to be very careful, and access is very common also actually. So we have to always test, we have to always create mechanisms and things when dealing with user input. So we'll look at a piece of code here. This is a simple application just like before, and we have a user route here, and then we can basically greet the user this. So the user can enter in their name, they can give in the name as a parameter, and it will be stored in the username, is in the username variable. And we can, and what we're doing is just basically printing greeting the user, which is basically saying hello and the user. So if the user is Enoch, it will just greet me saying hello Enoch. So this is a basic simple application here, and is running on this port 400. That's all. Now see, now let's test this code here. Now we have a name parameter, we're putting in the input as Enoch, and our name is being reflected back here. So it basically says hello Enoch. Now what if we try to kind of inject some kind of HTML payloads here? So we have a underline HTML tag here, and then we can see our name is being underlined. So this basically means that even the HTML code that we're putting in is being rendered onto the output screen. So that kind of creates a lot of possibilities, for attacks. No, so in this case, HTML injection is possible here. So what can we do more? What can we? How can we exploit this further? We can actually try to inject JavaScript code here. Now we have used the script tag here, and then we have used the alert functionality, and we have typed in message here, and we can see that the JavaScript actually executes on the browser, and then we can see the message here. XSS says hello. So what basically happened is that the script that we have, the script tag which we have used, is it's being passed on as input, and since we do not have any valid verification or mechanisms here, the browser is actually running the JavaScript code, and then it's happening here. In this case, there's nothing sensitive here. So always in XSS, you have to have an impact here. So since this is just a demonstration website, there's nothing actually sensitive here. But if this was in production, if there was a web application running in a production server which has users and sensitive information stored in, this would be disastrous. So now there are a few types of accesses, but we will not be going through that. Our goal is to understand why we should not trust user input, and how to sanitize it, how to sanitize user input, and then review the code. So that is our goal here. And we'll also see how we can implement the functionality safely. And we'll review a piece of code now here. Now this is the same code as before, but we have added a few mechanisms for uh, to prevent, to have a defense against this kind of attacks here. So one way where we can have is we can escape the HTML characters. So whatever the user inputs, whenever user inputs any HTML characters or any illegal characters, we can actually replace them with things with strings that actually won't reflect back the user input. So we have a few mechanisms here. We are replacing a few characters here basically. So all those strings will be replaced to the appropriate safer strings, and it won't cause the browser to actually render if an input if a illegal input, or if an HTML tag is used in the user input here. Now we have used a functionality called escape HTML here, and we have defined what it must do. So what we're basically doing is, instead of directly passing in the user input back to the user UI, we're actually verifying if the input contains any of these illegal characters, and if it does contain, we're actually replacing it with valid strings here. Now when we try to execute payload, now we have used an h1 tag to actually try to create try to make the browser run HTML code. Now when we do that, none of these payloads actually work here, because all these are replaced by these mechanisms that we have created here. So in this case, we have given the h1 tag and we've put in a message here, but we did not get any any output. Thus the HTML does not get entered into the user interface. And we have tried a lot of payloads here. I personally have used burp suite to run a few payloads, and none of them work because we have safely escaped all these characters here. So this is one of the ways where we can restrict inputs from the user. Even though the user puts in HTML tag, none of this would actually render to the screen. So as you can see, we have tried all these payloads and none of them actually work here. And how we can prevent that. So one method which I've shown you is that actually replacing the characters that we receive in input. And the other way is that how is that this is the first thing that which I've implemented. We're filtering our inputs. So whenever we get any input from the user, which we are actually filtering it out. We actually um, preventing those things from actually being rendered, and we have replaced such inputs with valid strings here. And then we can encode data on output whenever we are giving, or whenever we are displaying the output back to the user. We can actually encode it, and then or we can actually sanitize and then pass it to the pass it to the browser. So those mechanisms are also possible. We can use appropriate headers. So if we have a page that should not run JavaScript code, we can have content. The HTML headers such as this X content type options, and then we can restrict the browser from running JavaScript code here. So we can use this. This is one way also to actually prevent the browser from running accesses. We can have content security policy where we do not where accesses is like almost eliminated, and even though access is possible, the impact is eliminated, and we can actually implement those features also, the content security policy feature, to actually reduce the risk of accesses. So and then next we have command injection. So this is also one of the most common issues that we see. And although command injection is not as popular or as effective now, it is still seen in the wild. So even though it's not so easy to exploit command injection, it is still possible to do that in some of the websites. So it still actually happens quite often. And it basically happens because we are using unsafe functions like execute system and all those things, right? So what we're doing is we're basically trying to execute inputs that the user has put in. So we'll look at the code after this. Now it basically happens because of lack of validation. So all these two issues, all these two topics which we've covered, basically revolves around the same thing. User input is not being sanitized. So because of this, it is possible for injection and all those issues here, and that is one of the most important reasons why these issues actually occur. And then command injection, the impact is severe if the if a malicious attacker, they're able to actually pass in any of the commands, and then it's actually run by the system. It can be disastrous. They can actually have take control over the entire system if the input is being passed on without verification. So they can basically run any commands that they want. They can modify files, or they can also get unauthorized access also. So now let's review the code here for command injection. So what we're doing is basically we have a route call list. Now this code basically, what it does is it lists the contents inside a folder. So the route list takes in a parameter, and we can pass in a folder name. And if the folder exists, we're going to be uh, giving the output of the contents of the folder. We're going to be listing the contents inside the folder. So if the folder does not exist, we're going to be sending an error saying that the folder is non-existent here. So it's a simple piece of code, and as you can notice, we have no mechanisms for verification or nothing. So let's try to exploit it. Now we have we have a file called files in our in our directory. So um, when we give in the files parameter, so as you have seen in the previous examples, inside the files directory we actually have something called hello.txt, and when we give in the files input here, it lists the contents of the file, I mean of the folder. So we have hello.txt inside the files folder here, and then it displays, see, it displays right here. So we're using a Linux system for this, and that is why if you look in the code, we have something called ls.l. So it will list out the files, I mean the contents inside the files folder. Now this is actually flawed completely, and we're able to see the if I can get this right, yeah, we can actually pass in commands. Now now let's try to pass in some kind of etc password, kind of malicious input here, and then there's an error saying etc password, and there's no file or directory here. So this error message actually kind of reveals the system structure, and we can see that it's running ls.l command, and then we're passing in the cat command. So this actually is not a valid a valid input in the Linux system. So it actually gives the error message here, and this is why we mentioned that we should not be giving out too many information or too much information when we give out an error screen, I mean an error information output. So because of this, the attacker can actually understand what's happening behind the scenes, and they can craft the payload accordingly. Now we have to even from an attacker's perspective, they need to be careful, they need to be looking at all those outputs, and that will give them an idea how to exploit or how to leverage this further. So in our case, we can see uh, like we have ls.l command, although it's not visible to the attacker, but when the error is actually displayed, they can see what's actually happening behind the scenes. Now the attacker can actually bypass this kind of issue that they have here. So in Linux, we can combine multiple commands by using the semicolon here. So what they can do is they can actually after after giving a valid file name, they can pass in the semicolon, and they can uh, type in the literal Linux commands here. And then now what we're doing is we're basically catting out the contents and displaying out the contents inside the etc password file. Now because this payload works, we can see the the output of the etc password here. Now that is possible because of the semicolon, because we can combine multiple payloads using a semicolon here. And why is this happening? Now if you look back to the code, we have no mechanisms at all. We basically have taken the user input, and then we are passing it to this command here, and this is the flaw in the code here. Now we can prevent this types of things. There are a few methods for that, and also as we mentioned before also, we must always validate and sanitize user input. We must not pass in any of the user input directly without proper validation or proper sanitization. So we can have a whitelist of permitted values. So that is a good idea to defend against this kind of attacks. And also we must completely avoid using functions like eval or system or execute here. So because we have used execute function here, it's actually flawed. We must never pass in user input to this functionality. It is known to cause errors and, I mean, security flaws. So we must completely avoid. There are better ways to actually list files and list the contents of files here, rather than using execute or eval or system functions here. They actually allow attackers to run harmful code. So this usage of these functionalities should be completely avoided in all cases. And Also, we've mentioned we have to always escape special characters. We must not allow, either we can prevent the user from entering any special characters, or we can sanitize those things also. So we must always take care of the user input and always filter out any malicious or any special character, and or we must kind of sanitize them. And principle of least privilege, as we have discussed in the starting, we must consider all user as malicious. We must never give permissions that are required, that are required more than that what they desire, I mean deserve. So we must never give extra permissions to any user. And if we do that, that actually introduces a flaw uh, for things like privilege escalation and stuff. So we must give the user every user the least privilege, and we must always be careful about giving privileges to any user. So, and also, now we have reached conclusion. We've almost done with the slide, and now let's review what we have learned today. We have seen the basic structure of secure coding and the basic principles of security coding. We have discussed why secure coding is important, and in development cycles, why secure coding is actually quite important, and the need for testing code is kind of very important, and it should not be neglected. We have seen SDLC and STLC life cycles, software development and software testing life cycles here. We have seen the process. We have seen how each of these life cycles work. We have seen the phases inside each of the life cycle, and we have discussed also about fundamentals of secure coding. We saw why we need secure coding, the importance of secure coding, and what happens if our code is not actually secure properly. And we have also looked at a few code snippets. We have looked at path traversal, command injection, and excesses. So we have seen those code. We have seen the flaws. We have seen how developers can make mistakes in the code, and we have also seen the result of not having proper validation or proper sanitization of user input. We've also seen how we can fix those issues, and we've also looked at like the ways which this can be prevented, and how to improve the code quality, and how and we've also seen looked at quite a few functions that we should not be using when writing code. So I think that is all about today, and we have actually covered quite a bit. I also again apologize because the slide was not visible in the starting. I apologize for that. Now, if you have any questions, um, you can ask now, and you can also follow me on LinkedIn, and we can connect there. Feel free to connect there. And thank you for sticking around. And we will have 1 or 2 minutes for questions and solving doubts. So if you have anything, you can ask now. That's a good question. What are the most common challenges faced in JavaScript code review, like style complexity, compatibility, and so on? So, what I would, in my opinion, code complexity is one of the challenges. Yeah, that is one of the that is a good point here. Code complexity. So as the code base, tries to as the code base increases, and the complexity also increases, so there are chances that we do not uh, have proper knowledge on the workings of the code, and then that may increase the complexity, and we might miss out on things. So that is also one good thing. So in that case, tools like sync and all those OS tools actually help us find flaws, and we can have a good starting point when we use those tools, and we can actually try and understand. So that is why it's always important to break down scripts. We can look at specific functionalities. We can look at if you're taking any user input, or if the user input is being passed through the to the code. We can see how the flow works actually, and it is quite time consuming, but uh, we have to do it. It is important, and the best ways is to split um, code to a new to a few pieces, and then um, explore further, and stuff like that. So, our slides emailed. Slides will be actually given. It will be presented. You can. It won't be. I don't think it will be emailed, but we will be releasing the slides soon. Yes, this method is like manually. So as this is a very basic introduction and is a very beginner level introduction, so this analysis is kind of manual. So we have looked at very basic code and code snippets, and we've gone through manually. It's also it's crucial to understand how code works by going through it manually, and only depend on tools when we know how things actually work. DOM accesses is actually out of the question here. I mean, we will not be covering accesses types, um, but in simple, I would explain DOM accesses being how you can change the structure of the document object model through using accesses. Um, and I would suggest a great resource by Portssugar Academy. They have quite a few challenges and quite a few labs, uh, and you can go through them and you can understand and actually exploit exercise types and all those things. So Portssugar Academy is quite a good resource for that. How can I improve my programming language? So I'm not a very good programmer. I'm not a software engineer, but to improve programming, I would say start building projects. So that would be a good way to actually improve in that. Have something in mind which you want to develop, and then just start doing it. So keep practicing, and of course, that is the only way to that. So any more questions? You feel free to ask. I'm not sure, Sebastian. Not sure if they will be releasing, but I'll be sure to uh, follow up on that. I'm a beginner in JavaScript, but I'm gonna learn deep in secure code. So what I would recommend is writing your code and then try to exploit it. Just as we have seen in my slide here, right? We've written a piece of code and we've tried multiple ways to actually exploit it. So I would suggest you write your own JavaScript code, learn the basics of JavaScript, and then try to exploit it and try to secure it. So keep building, keep trying to secure, and keep trying to hack it, keep trying to break the piece of code, and then implement more security measures. By doing that, you will actually learn the core security concepts. So source code, except for open source applications, source codes are actually not disclosed. So if you're working in a company, or if you're working as an application security engineer, you will be given access to the code base. So in that, you can actually read the code and you can manually analyze the code. But if you're not working in a as an engineer or something, you will not be having access to the code. So what you can do is you can actually analyze open source, open source GitHub repositories, and then you can try to manually read the code and find flaws. And you can report them also. You will be, if you're lucky, you will be awarded with a bounty if you do that. And also, automated tooling is only recommended once you know how things work. Starting with automated tooling right from the start, it's not recommended. Try doing it manually. Automation is all about saving time and not repeating the same things over and over. So only use automation tools when you have a good idea on how things are working. Is it necessary to learn JavaScript? If you're going for the web attacks or web hacking thing, or if you're going into bug bounties, then it would be a good idea to learn JavaScript, because knowledge is never wasted. You can always learn something from everything that you learn, and having JavaScript knowledge, you will have an advantage when you're actually performing hunting. So websites are actually made using JavaScript. So if you know that, you would have an advantage over others. It is actually a good idea to actually learn JavaScript. White box approach. Yeah, that's true. What we have seen now is a white box approach, because we have direct access to the code. A black box approach would be blindly, you would be sending out the payloads. You would not know how the code is working, or you cannot see the code actually. So In that case, you would be performing black box testing. You would be actually, you know, uh, working without the inside knowledge of the code. What you've seen today is white box approach. Yeah, that's correct. If you have any questions, feel free to ask it now. I'll be waiting for a couple of seconds, and after that, we're going to be closing the webinar. So if you have any questions, feel free to ask. Okay, I hope that's it. I hope that you guys enjoyed the webinar, and please let us know your feedbacks, and we'll see you in the next webinar, hopefully. There's one more question here. I did a JavaScript course before that, and I can understand how to improve. So the concept remains the same. You need to always, build something, build your own backend frame. I mean, backend applications. Build your own server, and try to exploit the flows. Um, so you will need practical knowledge in that. So keep building stuff and keep exploring security flaws, and you can actually um, try to exploit your own code or try to hack your own code. That would be a good idea to learn. And also, yeah, um, doing a course actually, if you do not implement it, actually it's not effective. So you have to actually code a bit, and then try to write your own backend applications. Try using Node and Express to create your own backend servers, and then try to exploit it. So that is one good way to understand. If um, that's what I said. You have to um, actually divide the code into small bits. You have to actually find common places where user input is actually be passed. So if you're giving 10,000 lines of code, and it is difficult, it is that that is true. It is difficult to analyze all those things, but you have to split the code. You have to find places where user input is being received, and places where when we're generating output, or you have to like look at functions where the user input is passed in as parameter or argument. So in that cases, try to divide those lines of code and understand the specific context, and then work accordingly. And also, yeah, if you know what's happening, if you have to do things manually a lot, you can depend on tools. That is how we do it. um, Imran, I don't think CW has any JavaScript course for hacking. But as I mentioned, if you want to learn more about JavaScript and exploitation of JavaScript, Portugal Academy has a very good resource on that. You can actually, try out those labs, and you can actually learn a lot. Uh, Sandeep, LinkedIn mail is not working. Thank you, Sandeep. We will actually look into that. Thank you for your feedback. Thank you, Imran. Okay, so I'm ending the stream here. Thank you everyone again for watching, and stay safe. Bye.